All right, let's go ahead and solve the 4th day of the advent of code in the TempleOS. Giant squid. Here you go. You're already almost 1.5 kilometers, almost a mile, below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see, and why can is glowing. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Does it have anything to do with the problem? Maybe it does actually, who knows. Bingo, oh, it does actually have something with the problem. Bingo is played on a set of boards, each consisting of 5 by 5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards at which it appears. Numbers may not appear on all boards. If all numbers in any row of any column or the board are marked, that board wins. Diagonals don't count. The submarine has a bingo subsystem to help passengers, currently you and the giant squid, pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. For example, here is the things, and here are the boards. For some reason we have 3 boards in here. Yeah, maybe you have to count how many wins you have or whatever. I don't fucking know. After the first 5 numbers are drawn, 7, 4, 9, 5, 11, there are no winners, but the boards are marked as follows. Shown here adjacent to each other to save space. Okay. After the next 6 numbers are drawn, there are still no winners. Finally 24 is drawn. At this point, the 3rd board wins because it has at least 1 complete row or column of marked numbers. In this case, the entire top row is marked like this. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on the board. In this case, the sum is 188, and then multiply that sum by the number that was just called when the board won 24 to get the final score. To guarantee victory against the giant squid, figure out which board will win first. What will your final score be if you choose that board? It is easy. It is fucking easy, but there is a lot of just parsing in here. Okay, so here's the puzzle input and the puzzle. Okay. Parsing suffering. Well, that's everything I have to say. The only thing I have to say is, Ever, why would you do that to me? Okay. Advent of parsing, by the way, yes. Advent of parsing, another one. Okay. So let's go into AoC 2021. Dear MK04, there we go. 04. And let's do ed main.hc. And I need to cd, forcing cd home, AoC 2021-04, and I guess that's it, right? So, and I also need to include c home 2021 common hc. Okay, so, and we're gonna start with the part 1, right? So this is gonna be part 1. If I try to compile the entire thing, everything seems to be compiling, which is good, So, you know what, I think I'm gonna start with actually bringing the data to the TempleOS, right? So let me quickly do that. So I hope I saved it. I don't remember if I saved it, because I accidentally pressed Shift Escape, which means don't save anything. Okay, so it actually saved everything. I'm super happy. All right, I'm gonna do mount AoC 2021. And I'm gonna go into MMT, home, and AoC 04. All right, so I want to have a sample txt, right? So let's actually start by providing the sample txt. So here is the sample txt. I'm gonna go into the insert mode. I'm gonna include that, and I'm gonna save everything in here. There we go. So cut sample txt. Here is the sample data. Beautiful, absolutely beautiful. Okay. Interestingly enough, I'm gonna do ed input txt. All right, and I'm gonna just grab my main input in here. Get your puzzle input. Okay, I'm gonna include that, and then I'm gonna save that, and there we go. Cool, we have everything in here, hopefully. So I'm gonna go back, and I'm gonna run the AoC 2021. Alrighty. So it's a little bit slow for whatever freaking reason. I'm not sure why. But it is what it is. Why is it so slow right now, all of a sudden? Okay, so this is the fourth one. So SV. SV begin, file, read, not reader, but just read. And so maybe I'm gonna have something like input file, right? So we're gonna have input file, and then we're gonna have SV size. There we go. And then I wanna have something like save begin, which is SV begin. Let's go ahead and define input file for now. For now, it's gonna be sample txt, right? So this entire thing has to be something like this, and then we're gonna free the save begin. So we free the save begin. All right, so here is the interesting question. How are we gonna manage the memory and shit? Right, so how are we gonna manage the memory? For a single board, we can kind of allocate, we can kind of create like a separate structure and whatnot. For this one, so how many numbers do we have in here? Let me quickly count. So I'm gonna query replace this thing with space. And then we have 100 words, right? So we have around 100 words. So I can have a static array into which I'm gonna just push those things, right? Should be pretty straightforward. So we're gonna have numbers count, which is gonna be actually numbers capacity, right? So we're gonna be 128. And I'm gonna have I64, I64 numbers capacity, Sometimes I type too fast for TempleOS to actually handle all that. I don't think it's TempleOS, it's maybe because of the QEMU, like it's a little bit of latency in here. I'm gonna call them nums. So I don't have to type too much. So this is going to be nums, and this is going to be nums cap, which is the nums capacity. And in here we're going to have I64 nums size, which is initially 0. So, and one of the things I want to be able to do, I want to push them, and I think I'm going to do that manually, so it's not that big of a deal. It's not that big of a deal. Right. So I'm just thinking, what's going to be the easiest way to approach this entire stuff? So I can probably use str to I64, right? And I think it even will work. But I'll have to like chop off like a single character out of this thing. So yeah, let me actually do that. I have an interesting idea. While SV size is greater than 1 and SV begin, right, and we're gonna take a look at the first thing in here, is not equal to new line, because I think at the end here we have a new line, right? So it's not equal new line. What we're gonna be doing essentially is nums as z++ equal sv chop I64, where I provide sv, and the radix is going to be 10. Okay, so after that, so there's a new line. After that, I think the easiest way to skip that comma would be to increment this by 1 and then decrement size by 1, right? So, and I think I want to actually like move this operation into like a separate function, right? You know what I'm talking about? So u0 sv chop chop left, and we're gonna accept sv, right? And it just like chops a single character out of the sv, right? Something like that. And since we're passing this thing by a pointer, I'll have to replace it with arrows, right? And Terry didn't fix that mistake of C design, unfortunately, but it is what it is. Right, so after that, what I do is basically sv chop left. Right, sv chop left, and I just provide this thing in here. Though I think it would be rather useful if you could even say how many characters you want to chop. Right, so we can provide something like i64n, and then you'll be able to use something like this. And then to like not modify this piece of code, I can say that by default it's going to be 1, right? And then after the session, we'll be able to move this code into the common parts because I think it's going to be useful in the future. All right, so in here we're basically parsing all of the numbers, and after that we can just see how many numbers we parsed. Let's say parsed d nums, right? And in here I'm going to do nums as z, and if I try to run this entire thing, it says that it parsed 27 numbers, right? But we're using sample, right? So if I take a look at the sample, do we really have 27 numbers? I think here you have 27 numbers. All right, if I quickly switch to the input, right? Super Cali subscribed with Twitch Prime for 6 months. Thank you so much for Twitch Prime subscription, and welcome to Epic TempleOS Club. Okay, so if I do something like this, define input file, and this is going to be input txt. So I actually want to have something like if 0, right, and then else, and then we're gonna have and if. There we go. So now I can flip-flop between the sample and the input, and as you can see, we have 100 numbers in here. So we're successfully parsing all of that, right? We're successfully parsing the first row, right? So this row, we have all of the numbers, which is kind of cool, not gonna lie. Okay, bye-bye, Jay. So now I need to read all of the boards, right? So, but to read all of the boards, we need to probably define the notion of the board, right? So let's define some sort of like a class, and this is going to be board. And as we know, the board has a predefined width and height, I think. So in the sample, it's 5 by 5. They already said that it's 5 by 5, and it doesn't change in the main input, so I shouldn't even worry about that. So I can probably do something like define board size, and it's going to be just 5. And then, wait, I probably, okay. So I'm going to move this a little bit here. Right, it's going to be something like this. Class board, i64. And this is going to be basically cells, board sz, board sz. Interestingly enough, do I want to store the board like this, or do I want to store it like this? And can I store it like both, actually? Can I do something like union? And then say here that I have like a square. So this is a square, and i64 linear, which is the board as z multiplied by board as z. Is that a thing I can do in TempleOS? Because that way, for instance, I want to read it into like a linear thing, and then when I access it, I want to access it as a square thing. So basically, I want to be able to look at it at different angles. That's actually very interesting. What do you guys think? So let me try to do that, I suppose. So I'm gonna go in here and comment it out. comment out this entire thing, and let's do something like test board, right? So we're gonna have test board, and let's define a function that tests the board. U0 test board, right? And we're gonna basically define board in here, so I don't really want to type too much, so this is gonna be B. And the way I'm gonna operate is essentially I'm gonna iterate starting from 0 up until maybe board size multiplied by board size plus I, and then here I'm gonna basically access the board linearly and assign I to it. Right, so this is basically what I have in here. It doesn't compile because I forgot semicolon in here. Right, did I forget a semicolon? I think I did. So there is another problem at 25. What do we have in here? So I don't see the problem. What exactly did I forget? Invalid L value. At board size. Oh, it's not a board size. Okay, so it's actually board SZ. I wonder if I can just like replace size with SZ if I do Control F. So size and replace it with SZ, and then I'm gonna press space, escape, and then I'm gonna say replace, replace. Okay, it feels like maybe it worked. Yeah, okay, this has actually worked. So I can basically query replace things. How about that? That's already not bad for a TempleOS text editor, so yeah. Anyways, so if I try to run this, everything seems to be running. So now I should be able to access things by rows and columns, right? For I equal 0 less than board size plus I, and then for J less board. Why I keep doing size? It's SZ. I need to get used to that. And then essentially what I do in here, I need to print the number, right? So it's going to be D. Can I specify the width of the number, like things like that? I'm pretty sure Terry implemented something like that, right? Because it's very useful. Right. And then, so this is going to be the space, and we're going to take board as a square, IJ, right? So, and because of that, I'll probably have to add the curly braces in here. Right, so here are the curly braces, and in here we're gonna have like additional new line, and if I try to test this entire thing, it works. So yeah, I just wanted to test if I can have a union and just look at the same data from a different angle. So at one angle it's a linear thing, so I can just linearly read things into it, and then I can treat it as a square, which is rather convenient, as you can see. So yep. Okay, so let's remove the test board. Let's remove the test board, and let's go. So this is gonna be that. This is gonna be that. Part 1. Okay. How are we going to be doing all of that? So essentially, we need to keep repeating everything until we have any input. Right, before that, I probably need to also allocate enough memory for the boards as well. So let me see how many boards we even have in there. So let me do something like this. It's going to be temp2, right. So can I just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what? I think I can quite easily do something like this and count the amount of lines. Right, so there's a 600 lines. There's a 600 lines, which I can divide by 6. And this is roughly, so we roughly have 100 boards, right? So we have roughly 100 boards. Alrighty, so let's do something like this. Define board capacity, and it's going to be 128 just in case. And this is going to be boards, board capacity, and here we're going to have I64 boards size, which is initially 0, right? So, and while SV size is greater than 1, the way we're going to be approaching this entire thing. So we know that there is like a new line, and maybe I can do SV chop left, SV chop left SV. There we go. All right. How I'm going to be approaching all of that? Essentially, I'm going to do for I equals 0 less board as z multiplied by board as z plus I, and what we're gonna do. So board's size, so that points at the current board that we're currently filling in. Then we take the linear representation and we assign basically the next number. So it's going to be SV chop I64 from SV, right? So chop I64 actually filters out the spaces, so we don't have to worry about this kind of stuff. So yeah, for the rest of the stuff, we don't really have to worry about that. All right, and after that, excuse me. So we filled the board itself, and then I do board size plus plus. There we go. So that should mean that we read all of the boards. Parsed d boards, and we're going to do something like this: boards sz. So, and something went wrong at the line 44. And at the line 44, what do we have? I think we don't have I, so let's actually allocate the variable I64. All right, so, and we read 3 boards, but this is the sample data, right? So if I take a look at the sample, we do in fact have 3 boards. Rather convenient, isn't it? I think it is. So one of the things I wanted to do is actually dump the boards, like have some sort of a routine that dumps the board, just to be able to see them, right? So let's actually go ahead and implement such routine. All right, so let me go ahead and do that. Dump board, and we're gonna accept the board as a pointer. All right. And we probably need to allocate all of these things. I64, J. Okay, so, and we store that everything row-wise, so that should be fine. 0 less than board SZ plus I. For J equals 0, J less board SZ plus J. And in here we're gonna say something like 02. I wonder how can I put spaces in here? Probably should be able to do spaces. We'll see. I forgot how to do the spaces. This is gonna be D space and board the square representation with I and J. Alright, so with I and J, and this is gonna be the new line. There we go. So after that, after we parse all of the boards, we can try to maybe print them, right? So this is going to be for I equals 0 less than boards SZ plus I. So, and we're going to do the following thing. Maybe I'm going to actually do it like this. So dump board, boards I. And there we go. So maybe I should also separate them by some sort of a line or maybe new line, so you can see, you know, the difference between them. All right, so that didn't work at the line 25. So what's up with the line 25? So this is a single board Z, because there's no such thing as K. So I have to use J instead. All right, and it worked. So here are all of the boards as far as I can tell, and I think they are the boards that we were trying to parse, right? Aren't they? I think they are. So 20, 13, 17, 00. And the question is, like, how can I, you know, put space? Can I just put space in here? And it obviously didn't work. So does anyone remember how to space with spaces? Is that a thing you can do? I don't remember. Okay, printf pad with pad number with spaces. Left pad printf with spaces. Okay. If it doesn't exist, I can. So it has to be like, I mean, it's a first string. Whatever. It is actually okay. Space. I'm sure if it's gonna work for this thing, but we can try. I mean, it doesn't hurt to try. So we're gonna put this thing in here and I'm gonna say 2, and it works. Look at that. That's actually pretty cool. Okay. So let's go. Uvu. We have everything to to finish this stuff. So another thing I probably need to have is an ability to mark the numbers, right? So ability to mark the numbers that we already crossed them. And this is where like searching linearly comes in handy, because like it's super easy to just like iterate linearly and just like find this thing and just cross it. But we also need to like store the status of the number. We need to be able to store the status of the number. What's the easiest way to store the status of the number? The numbers are actually really small, if you think about that. So what I was thinking is that they don't exceed probably 128, right? So they do not exceed 128. We can try to basically use one of the bits within that number as an indication that this thing is already taken or not. That's actually pretty cool. Right, and furthermore, we can quite easily just access the bytes of the number already because it's I64. Just a second, so this is I64. Yeah, there we go. So we can already access the parts without any bit operations or anything like that. We can just basically use one of the bytes, right, to indicate that it's taken or not. Is that a cool idea? I think, maybe, I don't know. I kind of want to make a small break. So let's actually make a small break, and after the break we're gonna implement this entire idea. So all right, so let's actually test this idea. So I think the easiest way to test that idea is to actually modify dump word. So let me see what are the fields that are available for this thing. So this is gonna be I64. Right, and you can access it as U8, right? So it's basically U8. What if I already forgot how to access it? It's so easy for me to forget. So yeah, it's a field U8 and U8I, and there we go. All right, so this is going to be S U8, and if I try to put like just 0 in here, when I'm putting 0 in here, do I access like the yeah, it's a least significant byte, right? So that means I'm accessing the right thing here. So this should be correct, actually. This should be correct. So if I try to run this entire thing, and it is in fact correct. So, and what I'm saying is essentially we can store the information about this thing being taken out in a second byte. Right, so here we store the values, and in the second one we're gonna store the whether it's taken out or not. So maybe we're gonna have like some sort of constants for that. All right, so it could be something like cell value, which is 0, and then cell crossed, which is 1. Right, and here we can do something, maybe a cell, like, yeah, it's a very small program. We don't really need to prefix things too much, so I can probably put something like value and crossed. Right, so this is going to be value, and then in crossed we're going to store whether it's crossed or not. So it's actually pretty goddamn cool. Okay, so let me see how we're going to do all of that. So after first, so this is a 7 4. After the first 5 numbers. So is there any numbers repeating in here? I suppose, yeah, they explicitly said that they're not repeating, which is nice. Oh, this is very interesting. Since they're not repeating or anything like that, it could be used for some sort of optimizations, I think, maybe. Right, so maybe the fact that they're not repeating could be used for some special data structure that makes certain operations faster or something like that. But I don't think it's going to be needed in here. It's only first day. Teapot 418, nice reference by the way. Thank you so much for tier 1 subscription and welcome to our epic Temple Club. That's right, we're a Temple Club now. Cheers. Alrighty. Excuse me. Let me see. So anyway, I wanna have an operation that lets me just cross, you know, a specific number across all of the boards. Maybe I'm gonna actually start with like a single board first, right? So U8, cross in board, right? So this is gonna be board, board. And also we're going to accept the value, right? So it's going to be U64, but in this case, maybe it's going to accept like U8, right? So it's a specific value. Zero Mishu. Thank you so much for tier 1 subscription. Thank you. And welcome to Epic Temple Club. That's right. All right, so maybe I'm gonna actually follow the TempleOS convention. So TempleOS has a convention that first you provide the name of the object you operate on and then the operation. So we're gonna do something like board cross. And in this case, this is gonna be like board dump, right? So this is a board dump. Okay, so I need to allocate I64i for I equals 0, then less board SZ multiplied by board SZ. And essentially, if board linear, when we represented this thing linearly, I U8 value is equal to X, right? We do board Li U8 crossed, and it's going to be equal to true, I suppose, right? I know that true is a define for the 1, right? So we're just assigning 1 in here. Okay, so that's Pogue. Smooth. Let me try to compile this entire thing, and it doesn't compile. 71. So, and this is because this is supposed to be right, board dump. And you know what? I think we need to somehow maybe represent the information about certain things being crossed in the board, right? So I think it's going to be really valuable. So let me quickly do that. So if board, you know what? It would be nice to actually have a variable called cell where we could save the intermediate board or something like that. So I'm gonna do something like cell is equal board SIJ, right? So this is the cell, and what then I can easily check if cell U8 crossed, right? If it's crossed, we're gonna actually render it slightly differently, right? We're gonna render it slightly differently. The way we're gonna render it is we're gonna probably wrap it with brackets or something like that. I think that's a good idea, right? So then we're gonna put a space in here to cell U8 value like this. Otherwise, we're not gonna do that. We're gonna just put spaces in there. So here I should be able to just do that, right? And instead of the brackets for this specific case, this is going to be just the space. Right, there we go. You see what I'm talking about? Right, if it's crossed, it's going to be just in brackets, so we can clearly see that it's crossed or something. Okay, so That's very cool. But now it actually, yeah, it has a lot of extra spaces, which is fine, I suppose, which is fine. Okay, so we have board cross, and one of the things I want to do, right, while I'm dumping the boards, I'm gonna do board cross boards I, and I'm gonna cross. What I'm gonna cross? I'm gonna cross 7, right? So let's cross 7 and see if the 7 is crossed across all of them. There we go. As you can see, all of the 7s here are crossed. So yeah, pretty straightforward. Cool. So we now know when something is crossed and something that is not crossed, and we're actually storing that within like 64-bit numbers without wasting anything or anything like that. It's not really about wastage. Right, so I'm doing that not because I'm like don't want to waste too much memory or anything like that. I'm doing that because it's convenient to do it this way. It's just like, yeah. So I already defined an array of 64-bit integers, and the only thing I need is like extra information indicating whether it's marked or not. Do I have to create like a new structure or another array or anything like that when I have like a huge paddings between those numbers? Like, no, let's just use those paddings anyway, because the numbers themselves are really small. They're not going to be greater than 128, which is like a single byte. It's smaller than single byte. Right, we could probably even use a bit within the first byte. That's how small we, how little memory we use. So, yeah, I think it's kind of interesting. I don't know. So, and it's cool that TempleOS, like, not TempleOS, but specifically AoC allows you to just do that, right? So we have a 64-bit integer, you want to access it as two 32 integers, there you go. You can represent it as an array without casting or anything like that. So, it's just like, yeah, it's convenient. It's pretty cool. Never thought about it. Makes you think about things. All right. So, and now... So let me see. Right, we're now looking whether we have a particular row or particular column, right, filled in, marked in completely, right? So at this point the third board wins, and then what do we do? Sum of all unmarked numbers. So the score of the winning is started by finding the sum of all unmarked numbers on the board. In this case, the sum is but the sum of the number that was called just. I'm just thinking how I'm gonna check that the board is winning, right? So there should be something like boolean board. Board 1, right, board 1, and we're gonna just accept that. And it returns an integer, right? So it returns an integer, but it could win because of different reasons, right? It could win because of the, row, a specific row was filled in, or a specific column was filled in. So how do we distinguish between those? Right, I want this function to return not only the indication that we won Zulu, right? We will also want an indication that is that a row or a column win? Wait a second, it doesn't matter, right? Because we need the sum of all unmarked numbers, so it doesn't matter. So we don't need the numbers that are marked, so we can just return true. Okay, that's fair. That is actually fair, so I'm gonna just implement this function and don't care about anything. Okay, board 1. So how can we test all of that? So we can start iterating all of the rows and checking all of the rows, and then iterate all of the columns and checking all of the columns. Right. I64. So I'm gonna start with the rows. 0. Less than board sz plus I, right? And within each individual row, I'm iterating each individual column, right? So the j less board sz. And here is the interesting thing. So if board square I j U8 crossed. If it is not crossed, right, if it is not crossed, there is no point in checking this column anymore, right? There is no point in checking it anymore, so we can just basically break out of that loop, right? We can break out of that loop. There we go. But here is the interesting thing. If we never broke out of that loop, so here we can instantly return like right away that v1 Zulu, right? So let's actually do something like boolean 1, right? And at the beginning of the iteration, 1 is gonna be false, right? Maybe, yeah, it's gonna be true, in fact. So it's gonna be true. Right, then we iterate through this entire thing, and we're gonna say that 1 is gonna become false, right? It's gonna become false, and if here, if we won Zulu, we're gonna return 1. So which is rather interesting. Maybe because of that we can get rid of the break, if you know what I'm talking about, right? So we're gonna iterate while we won. Right, we can iterate while we won, and we can kind of get rid of the break. Furthermore, we can even maybe use this condition, right? So while it is crossed, right? So something like that. Okay, initially it's that. And as soon as it becomes uncrossed, as it becomes uncrossed, we can probably just break out of that loop quite gracefully. I wish the editor was a little bit easier to use, but it's not the case, unfortunately. You see what I'm trying to do in here? Right, you see what I'm trying to do in here? So, yeah. So it would be kind of cool to actually... Yeah, you know what? So to put that in a condition, right? Just put that in a condition, like so, and get rid of the variable completely. And we won when j is greater or equal board as z. That means we reached like the end of everything, right? So which kind of turns this into while loop, but not really, right? So it basically becomes an empty loop, if you know what I'm talking about. But that gets rid of the one variable, so you don't really need one variable anymore. So, but yeah, so that kind of creates this situation. Does it make sense? Right? I think it does make sense to some extent, but like with for loop, it's kind of like looks gross, to be fair, in my opinion. So here we can do something like j equals 0, then we can replace it with while. Here we're gonna have that, and we can move plus plus to like inside of the body. Just move plus plus inside of the body. Right, plus plus j. Right, you see what I'm talking about? So j initially 0, and if we reach that, but we're only checking the rows. Right, we're only checking the rows, but now we kind of need to check the columns. And I'm thinking, can we check the columns basically simultaneously? Can I copy paste this code, right? And essentially just swap around these things. So now j is iterating the rows and I is slowly iterating the columns. So we're basically checking all of that simultaneously almost. Right. Right, you see what I'm talking about? So that is very, very interesting. And here we should not return the 1, we have to return the true. Did I make any mistakes though in here? I hope I did not. I did not. Return false. There we go. Alright, so there we go. So let's take a look. So 51. Oh, I see what's going on in here. Right. Did I make any mistakes? Right. So far this looks reasonable, right? So I'm checking the rows, all right, and then Yeah, I'm basically doing like 2 checks simultaneously. All right. Okay, cool. So everything seems to be compiling. So we can now do the board win. Alrighty, so here we read everything, right? So we basically read everything, and I suppose I'm gonna just do like while true, because I'm not really sure what's gonna be the condition. Right, I'm not sure what's gonna be the condition, but I'm gonna do it like that. While I 0, I less boards as z plus I should actually call it boards count, but it's too late. Right, so, and what we do, board cross, I do boards I, and what I wanna, oh, I can just iterate, yeah, so essentially what I can do, I can iterate through the numbers, right? I completely forgot that I can just iterate through the numbers, so here is going to be the numbers. So it's going to be nums as z, plus I, and in here I'm just crossing this entire thing, I'm crossing I, but here in the inner loop I'll have to use the j, right? So this is going to be the j, there we go. So the board I'm iterating is the J board, right? This is the J board, and the number is this. And what's interesting is that after that, I can check whether the specific board in here won. Did it win? And if it in fact won, I can essentially just, you know, compute the result. Finally, we get to the point where we are computing the result, right? Finally, we are computing the result, which is rather nice. So, and what we need to do, we need to count all of the unmarked. So let's do something like board sum of uncrossed, and this is going to be boards I, and you have to multiply it by this number that caused the win, right? So this is going to be nums I, and this is basically it, right? So we're going to just print d like so, and we can even call it something like part 1. To be fair, even though like everything I'm doing in TempleOS is actually kind of slow, right? There is some sort of a zen to it, to be fair. I kind of like going slow on these problems, because every time I was doing competitive programming problems, I was always forced to do things very, very fast as possible. And I never like took time to just, you know, chew on the problem, just like enjoy the problem and just like write all of these like functions that show what is crossed and what's not, because you never have time. You never fucking have time, because you have to quickly, otherwise you're gonna lose, and it's just like, always have to write the messy code, and it's just like so fucking frustrating. And this is the most frustrating part of the competitive programming, is just like these time limits, always the time limits. Like, can we just like enjoy the problem and just like think about it and stuff like that? So this is what I was always missing in competitive programming. I don't know. Everyone is always like, you know, running somewhere. It's just like, yeah. I don't know. Maybe it's just me being slow. Board sum of uncrossed. Okay, so I'm gonna try to compile this thing just to see if there's any errors that I wouldn't expect. So I do not expect an error in here. So we don't have J. Let me quickly allocate the J. And the compiler is definitely like forcing me to like think about. I mean, not the compiler, but the editor. Maybe there is some advantages to all of that. Okay, so it says that, yeah, invalid value because this thing simply does not exist. Okay, so I probably need to define this function. Fuck competitive programming, go code golf. Code golf is actually super fun. I think I did one code golf programming session on this channel, and it was actually a huge success. People really liked code golfing. So maybe I'm gonna do another one. Yeah, I completely forgot about that one. But and on top of that, code golfing is extremely entertaining to watch. Right, as you start like writing the first version of the code, and then you find a way to make it smaller and smaller and smaller. That process is actually very entertaining, surprisingly. So maybe I'm gonna do another code golf session. So yeah, that was fun. Thank you for reminding me. Alrighty. Code golf and Holy See, but maybe not. I don't know. What is the code golf? Basically, you're given a problem to solve, but your goal is not to just solve problem correctly. Your goal is to write as little code as possible. Your goal is to minimize the size of your source code. You can use whatever hacky trick you want. So your code, like readability of your code doesn't matter at all. You can be as cryptic as you want. The main goal is to produce as small like code footprint as possible. And people compete with each other on that, right? So who can save the most amount of characters and stuff like that? You can Google it up. It's actually very fascinating. Code golfing. It is super fun. I really recommend to check it out. So I just want to show you some examples of the code. Yeah, for instance, this. Yeah. Oh, it's a golf script. I mean, who uses that? So it would be nice to just find. There's a code golf stack exchange, just to get the gist of what the code golfing looks like, right? Yeah, for example, this is Ruby code. This is supposed to be a Ruby code. But it's written in like with as little characters as possible. With as few characters as possible. So that's basically what code golfing is. So board cross. So what I was doing, I need to implement the board sum of uncrossed. Okay. Board sum of uncrossed, and let's go. I'm gonna copy paste this stuff, and I need to go back here. So boom. So in here I'm gonna return i64, and in here we're gonna accept the pointer to the board, and essentially now I can access it linearly. So it's gonna be i0, I less than board as z multiplied by board as z plus I, and basically if board linear I u8 crossed, right? If it is not crossed, right? If it is not crossed, we have to add it to the result. Board li u8 value, something like that. Yes. I think that's basically it. I might as well actually put a little bit of stuff in here. And let me allocate i64i result. Do we need anything else? I don't think so. And after that, I can just return the result. Okay, so we've got something. It did the thing. But it didn't produce any significant results, which is kind of sus, not gonna lie. Alright. And also we probably need to put this thing in here. Right. Before returning, and I'm gonna also put it in here just in case. Okay, so it looks like nothing ever won, which is really strange. Okay. So okay, I may try to just dump the boards and see how they go, right? Board, dump, and boards, J. Let me see, so what's going on here? Looks like they were never crossed for whatever freaking reason, okay. So yeah, they're essentially never crossed. So the cross operation doesn't work. Are you freaking serious? Wait! I roughly remember, vaguely, I'm sorry, not roughly, vaguely. Holy See doesn't type check. I vaguely remember that it doesn't type check. So basically, if you put like types in places where don't expect those types, it will just compile that thing, but it will not work correctly. So, well, we'll have to keep that in mind. And there we go. So we have something like this. Okay, so as you can see, everything is crossed properly and stuff like that. So makes sense. Let's actually remove this entire thing. Wait a second. Ah, shit. Fuck. Damn. Alright, so let me go back. So I didn't want to dump, I wanted to cross. Right. I wanted to cross, and this is gonna be the nums I. Right, so is it gonna work? Is it gonna work now? Yo, 63 is 60. Okay, so are we doing the samples? Okay, we are in fact doing the samples. And it is not correct already, so I can clearly see that it is not correct already. All right, so let me think. So this is nums, I'm iterating through nums I, then j, then I do board cross. Oh, okay, so I see the mistake. Okay, that's cool. Okay, 4560 on the sample. So this is the expected sample. This is in fact expected sample. That's a lot of code for the day 4. And majority of that code is just like parsing and organizing and like building machinery for the problem to solve. It is not particularly interesting problem, to be fair. Sorry. It's just like a lot of things that you need to do. Which is kind of sad, but it is what it is. All right, so this is part 1. For the sample, it works. Let's actually check all of that for the input, right? So let's take a look. So the input is supposed to be 8762, right? Hopefully, I don't know. 8762, and oh, it didn't even work. So 8762 didn't even work. So I wonder where exactly I made a mistake. So yes, not a gut cooler, by the way, not a gut cooler. That is really sus. So, and this is actually kind of sad, because on the sample it works perfectly, right? So on the sample it works perfectly. It's a 4560. Oh no, it is actually not 4512. I'm an idiot. Okay, of course. So there is a problem somewhere. So let me see. So I think I'm already tired. S-Sun3, thank you so much for 5 tier 1 subs. Thank you. And everyone who's got the subs, welcome. I'm a little bit busy right now. I'm sorry if I'm not addressing properly the subs. Okay, so yeah, so I saw 55 and I thought that it is correct, but in reality it is not correct actually, right? As you can see, it's that. So let me see. It is close though. It is kind of close. Oh no. Oh no. Yes. Fucking classic, of course. Freaking classic. Forgot to initialize the variable. Okay, let's take a look at the sample, at the input now, and it's 8580. Okay, so it's 8580, and first try. I'm gonna edit that out. So there was no first attempt. So this is first try. So this is the first try. We did it on the first try. Cool. That is a lot of code. Like, why? Why do I have to write so much shit? Anyways, so that's fine. That is totally fine. Everything's fine. Let's actually commit everything. So I'm gonna sync everything into the host, right? And I also have to provide all of that stuff. And let me take a look at the status. So I'm gonna add AoC, commit, so add day 04 part 1. There we go. I'm going to push that right into the repo, push origin master. So, and if you want to check out the solution, you can find it in here. So basically in the description, if you're watching live, I'm going to copy paste that into the chat just for you. All right, so let's continue to the part 2. electric boogaloo. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once. Oh. So rather than waste time counting its arms, its safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. So in the above example, the second board is the last to win, which happens after 13 is eventually called, and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148 for final score this. FK4OS, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic TempleOS club. Alright, so this doesn't sound that difficult to add. I'm looking at the description. I'm just like looking for a trick somewhere. Is there some sort of a trap or whatever? Like, do I understand correctly? Just like figure out which wins last, and so you basically keep playing until like all of them won, right? And then, is that it? Seriously? Okay. So one thing I can do, I can count like how many already won or something like that. Well, maybe I also need to keep like basically mark things that already won. Right, so that's one of the things. But maybe I don't have to. Maybe I can always recalculate the things that already won. So, yeah. Anyways, so let me see. I'm gonna start the run AoC 2021. Let's go. All right, so take tour. No, let's not take the tour. So this is going to be the deer and a boom 04, and then we're going to go here. So let me see. So it's going to be U0 part 2, right, something like this. Part 2. I'm going to comment out everything in here and just only start the part 2. Interestingly enough, I think we can easily extract like reading the input into a separate function. So let's quickly do that. Something like 0 read input like this, and essentially so this is reading the input, right? This is reading the input like so. And this is where we can just free this saved begin. We're just freeing the save begin, and because of that we don't have to free this stuff in here, because it's already freed by that thing. Yep. So this is a part 1. You know what's cool? We can actually read the input maybe here. So I just read the input. Well, you kind of want to read the input on each part. Right, because we're going to be like calling them in sequence. So read input in here, and then do this stuff, and then read input. And one of the things we want to have is like basically count how many already won. One CNT, right? And it would be nicer to actually like subtract them or something like that, but that's fine, I guess. So for I0, I less than, well, I forgot to also declare some of the variables in here that are super useful. 64 ij. So yeah, let's go ahead and just like make everything compile in here just in case, because you never know. Let me see. So unused variable ij, everything seems to be fine. Okay, so I did everything correctly. So board, actually nums size plus I. Right, so num size. Cool. Then I iterate through all of the... I can probably copy-paste a lot of this code. I'm pretty sure. I can do that. So here's an interesting thing. Like, I can try and optimize shit and keep track of who already won and stuff like that. But I can just basically recalculate whether the board won every time. And I don't think it's gonna take that much time, right? So the input is not that big, right? So essentially, we're only gonna consider the boards that didn't win yet, right? So the board didn't win yet, right? And we're gonna cross this thing. And if the board won at this point, right, if the board won, we need to basically increment one CNT by one, right? We increment one CNT by one. And if one CNT essentially is greater or equal to the boards as Z, that means we found it. That means we found it, we won Zulu. And I cannot see shit in this mist. And the reason why I cannot see shit in this mist is because the name of this function is extremely huge. Board sum of uncrossed. So let's actually take this entire shit and maybe rename it to something. I'm going to do Control F. Board, what should I rename it to? Board, let's call it sum. And I'm going to replace it. And there we go. Replace that, and there we go. So that's really cool. And something didn't really work correctly. What did I just replace it with? Oh, I see. Okay, so what we have in here is yeah. So let me cancel. So ampersand. I probably need to go here. So I have that, and I want to replace it with that, and replace. And that was only one instance, but it didn't replace all of them. Maybe I can do F3, and it didn't work. Maybe because I made some sort of a typo in here. All right, hopefully that will not create too many problems for me. So what I want to do in here is a board sum, and that's basically it. So this is also part 2. Right. So is that good? Is that Gucci? Is that Tamaguchi? That's the questions. That's the important questions I'm trying to ask on this channel. All right. So let me see. So it does not even compile, which is nice. Okay, 61. So it does not compile boards. Oh, because it also fucked up this thing. Okay, that's fair, I would say. That is in fact fair. Unused variable. Okay, 1, 4. So what do we have in here? I'm not sure what the fuck are you talking about, but it's only a warning, right? So we only care about the error. So the error 124. Let's go here, 124. And board 1. I don't see a problem in here. So boards, okay, I see now. All right, so we also have an unused variable, j in red input. So let's actually go ahead and fix that. We don't need this variable. So it's kind of ironic that it doesn't type check, but it checks whether you have used variable or not. So do you want to have like quality of life checks, or you do not want to have a quality of life checks? Like it's almost that it cannot decide. Though maybe the whole thing is simply not finished. Right, so Terry maybe didn't have just like time to finish this entire thing. Maybe all the features that the operating system, or did he say that it's finished? I don't remember. What was the conclusion on TempleOS? Is it finished or is it not finished? Because by looking at it, it doesn't feel finished, right? It has a great potential, but it still doesn't feel finished, if you know what I'm talking about. I remember what he said about that. Anyway. So let me take a look. So we're gonna take a look at the sample, and what's the value of the sample? It never freaking printed that. Cool. I'm super happy. So I can put something like this in here. So this is gonna be unreachable. And there we go. Oh, it never printed unreachable. So am I blind? Because it didn't... Oh, did I fuck it up yet again? So it's a part 1 though. So you're talking about this thing, it's a part 1, so it doesn't matter. I'm calling part 2. So it doesn't do anything. So this is the return. It prints neither this nor this. Am I stupid? So this thing didn't want. Okay, so can we print the numbers? Right. Num d, new line, nums I. Okay. Am I going crazy? It doesn't print anything? I'm missing, well, why doesn't it complain? No, it doesn't miss, it's just like it's colored gray. It is colored gray, I think. It doesn't print begin. You know what? I think something fishy has happened. Let me actually open this entire stuff in Emacs, just in case, super quick, just to confirm that I'm not going crazy, right? So, because the editor is kind of a poo-poo. I'm sorry, Terry, but it is what it is. So mount, this is not what I wanted, in fact. MNT, and I'm gonna go to home, AoC 4. Oh, why did it compile? Why does it compile? Holy fucking shit! Yikes! Ugh, this is so yikes! Holy shit! Okay. And of course, yeah. Oh boy. Yeah, anyway. So let me close everything in here just in case, and then I'm gonna run AoC. Thank you, Terry. Very cool. Alright. So. So are we on the sample? Right, so we are on the sample and we've got something. So is that the correct value for the sample? 1924, this is a correct value for the sample. I am super happy. How about the input now? So the input is 9576, right? So 9576. First row. Cool. Did it! So, do we have anything we want to actually pull out into like reusable code or whatnot? I don't think so. Chop left maybe. So the only thing I want to pull out is probably chop left. So let me quickly do that. Right, so this is a chop left. And yes. So I'm going to go to the common and I'm going to just put it in here and I'm going to save it. And then I'm going to go here. This is not really what I wanted, but yeah. Okay. And then if I try to run this entire thing, it is working. So let me quickly get rid of this extra output. Also, I would like to have unreachable at the end of the part 1 too, just in case unreachable, just to see what's going on. And the question is, can I do something like that? Can I reuse the same input? I think before reading the input and stuff like that, what I need to do, I need to zero out num size and also board size, right? So that way I would be able to call read input several times, right? Because it's gonna basically override the the data, and then I can just call that, and there we go. As you can see, we have like two solutions, part 1 and part 2, and that's everything that we need to know. 8580. Right, so return to the calendar. Right, so let me take a look. So the first one was 8580 and the second one 4571, and here are the solutions in here. So that's pretty cool. We managed to solve that. So let's do a committee and maybe even a pushy. So I'm gonna do sync host AoC. All right, so if I take a look at the div, in the div we just have some stuff. Right, so read input. Though, oh yeah, so we basically added part 2, that's why it's a different here. So add AoC, git commit, add day 04 part 2. I'm gonna git push origin master. There we go. Cool. So if you're watching on YouTube, you can find the source code in here. If you're watching live, I'm gonna copy paste the source code for you in the chat. So that was pretty cool. I do think so. But it's still too much code for day 4, I think. Right? It's just like, it's not even the parsing, right? It's just like a lot of machinery. There's just a lot of machinery that I don't wanna have. So let me see. So AoC 2021. There we go. Oh shit. So let's go in here. 04. All right, so I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Thank you for all of the subscriptions, for all of the support. I especially appreciate that, and I see you next time. So yeah, should we rate somebody? I don't know. Let's actually rate somebody. Is anyone doing anything interesting on the science, on the software development section? Is anyone doing something epic? Absolutely epic. So we only need to wait until the Twitch loads up. So Anthony writes code. Is he doing advent of code? I haven't read him for quite some time, to be fair. Python pre-commit, then baking later. All right, so let me take a look. 1 lives left. So is he doing like a game development of some sort? Jai, he's doing Jai. All right, so he's one of the beta testers of Jai, so let's actually rate him. He was here, by the way, at the beginning of the stream. I do remember him. So 1 lives left. Okay, so get ready for the raid, boys and girls. Get ready for the raid, and I see you all next time. Love you.